We're going to look at a beta VCR today. It takes these exciting tapes. It's never worked, and let's see if we can fix it. The one that we had a brief look at the other day, Sony SL-F1E, which is beta, PAL, portable VCR, battery connector, annoying non-standard AV in-out, which is annoying, and a DC in with a DIN plug, camera connector for Sony cameras, microphone. And when I got this, it didn't work, and presumably it still doesn't work. I think I took a belt off because the problem it has is as soon as you plug it in, the loading motor runs in the unload position until this opens, and then it just keeps running with the belt slipping. So we should take it apart and have a look inside it and see if we can work out what's going wrong with it. Got the power supply here, which can charge the battery, and this thing here, there's a PCM selector on it. Because you can use this as a PCM audio recorder, and then there's an input selection whether you want it line in or camera in. And then on this is the input and output cables. So annoyingly you have to use this to join audio and video in and out, which it's so silly to use a non-standard connector when there's room on the machine to put a proper connector for the normal connectors. And there's the power connector. This cable has gone really stiff. So I want to plug this in, and we'll see if it still does anything. Got a latching switch. Put this away for later. Need to zoom out some. And let's turn it on. Okay, let's turn this on. Oh, you can hear the motor running, continuously running. So it seems to have the same fault that it had. Oh, stop doing it now. Alright, maybe the fault's different. Let's take it apart. Oh. Okay, that might be a problem, because you have to have this popped up to get the cover off. Except it won't pop up because the belt's off. So the display lights up, and a light. I was wondering, is there a memory button, a counter memory, so we could test if the CPU was running enough to do that, but it doesn't seem to. It's got to reset and go to 0. I guess they use that instead of a memory. You just push go to 0. I have got a service manual for this. Maybe we could look at it to see how to open it. Where's the fun in that? Different screw. That's weird. There's a self-tapping style screw in that corner. Nothing's come loose yet. Okay, the bottom's coming off. Now we can see there are some wires. There's a flexible board-to-board connector there, flexible PCB type thing, and some of it's been replaced with wires because when I had a go on this thing probably nearly 20 years ago, I suspected there were some issues with the connections on that and replaced those wires, and it made no difference. It's pretty gross looking. It looks like someone's resoldered that. I don't know if that was me. I don't think so. Don't know. I wouldn't have used gross flux like that, which makes a mess. Soldering is pretty dodgy on this. There's blowholes in it, and lack of solder on some pins. blowholes in the wires. Yeah, so it hasn't been soldered very well. Interesting. Now, how do we get the rest of it off? Okay, I wonder what that was. Maybe it's that or that. There's some clip there. That's the battery release. Oh, I wonder if that was not plugged in or just ripped itself out. The wires are very stiff. Anyway, so here's the belt, there's the loading motor, and that just runs, or was, just running continuously until it ejects itself. Let's try that. There you go. Yes, and see it's straining itself still, trying to stay fully eject as possible. So you can't put anything in it because it's just eject straining itself. Alright, that means we need to study the circuits and take some measurements to see if we can work out why it keeps running. There you go, the motor's just running continuously with the belt off. Now, I did already have a brief look through the service manual at what controls the motor. Let's go and do that now. So there's the manual. And we discovered something. Why? Discovered something when I was looking through this. It tells you what that mystery button does on the camera. It says there, if you have a camera with a recording review function, such as the HVC 3000P, which is the one we were looking at, then you can check whether the recording has been made correctly immediately after you set the recorder into the record pause mode. Press the button. It says, if it's covered with a plastic cap, carefully remove it. Interesting, I guess. Yeah, stop you accidentally pushing it before you know what it does. I don't know. Anyway, that's what the camera had, and it wasn't detailed at all in the service manual, but there it is. It's in the user manual for the VCR. So we get to the circuits. That's video. We need some system control stuff. There's some CPUs. There's a common clock that gets sent to the different CPUs. Here we go. Threading motor, and it's got a drive, and it's got a load and unload direction line. Come through these buffers. It comes off the CPU 3. So I'm wondering if was one of those lines stuck high, or is the threading motor drive, is that damaged in some way and it's just permanently in a particular direction? So we're gonna have to locate these parts, and then we'll work out what to measure. So it says LM8 board, which I think that's just that there, the motor, although it says LM10. Threading motor drive, Q610, 12, 13, 14, 15. You think they'll be on here? And then the CPU that it comes from is IC602. So that's that one there. And then the inverter chip, IC604. What is that? The one that's been resoldered that someone's already had a go at? No, that's 605. There. That's the there. IC604. The buffer, maybe buffer inverter thing. So I have to check that that's got power. And then the transistor's 610, Q610. That's there. Okay, so all this stuff's pretty close. I wonder if this hinges up. Probably not. So I guess one of these wires here connected on will be the one coming from that motor. If we know the designator and the pin numbers, we can take a measurement on the buffer chip to start with. Let's go to the actual schematic where that is. Gives you lots of timing diagrams, waveforms. I guess we should check power supplies too. M3 board, that's where we are. Is this it? Yes, here we go. The two square chips. So CPU 3, IC602. So that's the one that we're interested in. And then the buffer chip here. Oh yeah, that's split into multiple parts. And then the H-bridge driver is here. And then that goes to the loading motor here. Presumably that works because the motor turns, so it means power is getting through from here. Do we need to look up IC604 pins? We need to check that pin 3 correlates to 4 and 5 correlates to 6. It says there TC4069, so that's a CMOS 6 inverters. So if we measure high on pin 3, it should be low on pin 4, and vice versa. And same with pins 5 to 6, they should be the opposite of each other because it's an inverting buffer. And the power supply for that chip, pin 14, the red track, I'm pretty sure that's a 5 volts, regulated 5 volts. So we should check that first, make sure the chip has a good power supply. Then we can check the state of the inputs and outputs. Yeah, if the power supply is no good, then there's no point checking the inputs and outputs because we can't rely on them when the power supply is bad. So I need to find a meter. We'll get this out of the way. IC604. Pin 14 is there. If you see that, then you won't be able to see the... there's also no room to plug in the power. Okay, the power supply is connected. Now, pin 7 is ground. Pin 14 is the power. So then if it's dry joints, you're going to fix those by touching them. So yeah, so you can't even rely on probing things sometimes. Let's turn it on. There you go, 4.95 volts. That's pretty close to 5 volts. It's not fluctuating around, so it's probably fairly stable. Then let's take a look at some of these logic connections. Pin 3 to 4 with ground on pin 7. 1, 2, 3 is low, so that means that should be high. Yeah, it's pulled down, but okay. And then 5 and 6. 5 is low. Seems like both are driving. I'm trying to. So it seems like both pins 3 and 5 were low. Well, not that low. That makes it difficult because it's not really low. Low would be below, should be below 0.2-ish. Says there on the drawing 5 volts, 0 volts. I wonder what situation that's under. Probably, oh yes, look, it says there. No mark, record mode in brackets as playback. Yeah, because that's not loading and unloading, is it? So by default, it should have 5 volts on the input. Okay, we didn't see that. We store 0. Wow, we saw 1.5, so that suggests the CPU might be dodgy because it's not driving a determinate state. So that comes from 45, 44, which is the pin numbers on that. CPU 3, which is that thing there. IC602. What I want to do is desolder that chip so that there's no load on these lines, and that way you could tell whether this is driving correctly when there's no load on it, and also it allows you to determine which direction the problem lies. There is some corrosion on the board. I wonder if there's capacitors leaking on the other side. Wouldn't be surprising, would it? So we should probably check. It's weird there that it says 1 of 2 of the same chip. I mean that's half of it, and the other half should say 1 of 2, 2 of 2, so that you know. Oh, it's nice. It says it's an inverter. That's helpful. So we should probably check. We need to get a scope to see that the chip's being reset properly, and that it's got the clock signal correct, and the clock comes from a clock generator up here. There's a 4 megahertz crystal, and then some sort of inverting buffer thing to drive the crystal, and then that clock comes out there, and that goes over down here into there, and then into the other CPU, this one, and maybe to other stuff. So we should check that's working, because if there's no clock, then the I/O lines of the CPU are going to be in an indeterminate state. Similarly, if there's no reset being generated, because it means the program counter won't start at the beginning, and it will just be executing some arbitrary stuff. But we need to find a scope for that. Okay, there's probably a clock there. Look at that. We caught a sine wave. We go to measure 4 megahertz. So I think the clock is working fine. That's good. Is this thing getting a good reset? That's the next issue that we need to check. Where is the reset pin? One over from the crystal. There's the blank one where the crystal output would go if you're having a crystal directly connected on, and then it's the reset. In order to capture this though, you really need another probe on the power supply, so you can see when it powers up that trigger on the power supply rising, and then see if there's a reset while the power supply is rising. So we need to find the power supply, which will be those three that are joined together, the VCC. So I'll configure the scope for that. Maybe rising trigger on channel 2 once it crosses about 2 volts maybe, and then we need some sort of milliseconds time base, because it's going to be milliseconds. Okay, let's see what happens. Is it an active high or low? It says active low, and it doesn't look very good. I don't see a reset pulse. Maybe. Let's try that again. Oh, yeah, it might have 100 milliseconds of reset. Yes. I'll just try and get a good capture of that. Okay, you can see there that on channel 2, that's the power supply, 1 volt per division. So that goes up 1, 2, 3, 4, 5 to 5 volts with some pretty angry ripple on it. And then that's at 25 milliseconds per division. And so 100 milliseconds later, the reset line, which has been low the whole time, goes high. So there is a reasonable reset given to the CPU. So I guess the problem's something else then. The next step would be desolder the inverter, see what happens to those signals. Perhaps we should check the signals with the scope first, just to make sure that there's nothing weird going on. Alright, we're going to try probing the input to the buffers to see what's there. Pins 3 and 5. 3 and 5. Oh, it's dodgy. Oh, it's clean now. Oh. Huh. Now it turns on fine. But before it was... And the motor's not running now. Still doesn't seem to respond to anything, because when I press eject, the motor doesn't start up. So it's normal now. The motor is not running continuously. Let's tip it over and put the belt on and see if it will behave normally. I guess the answer is no, because otherwise it would eject, wouldn't it? I guess that's another fault of it. Alright, so when the motor was running, both lines went, they appeared to have like a PWM, like a switching noise on them. Ah, well that would be why we measured a kind of low voltage on the multimeter then, because it's seeing high and low transitions. Did the loading of measuring this mess it up? So what I want to see, if I measure on the input side of those buffers, turn it on. Oh, it's gone back to bad now. Oh, now it's good. So now it's in the eject position because I put that belt back on. What I wanted to see was when it is not running the motor continuously, if you press eject, will it try to run the motor to do the eject? Well, I can't really tell if eject works because the button doesn't seem to click. Do you think the button is... Is it as easy as the eject button is wrecked and it was just always being held in? The clock's definitely still there. It is a little bit concerning that the voltage is so... Oh, the power supply is so noisy. It's got almost a volt of ripple on it. Probably too much. Maybe we need to replace power supply capacitors first, because that could be glitching the CPU. Ah, look there. That is voltage regulator. I think what it says, oh, it says reg 9 volts. There's other stuff that's been touched up there, and there's some relays. Maybe that's the relay that clicks when it powers up. And all the other buttons click. The eject button doesn't. It suggests there's something wrong with the eject button, in addition to all the other things that are wrong on this. Let's see if we can peel this open. Does this come off? Okay, now the eject button will push. Still got this problem though. Didn't make any difference. I was wondering maybe we should put a tape in it. Do you think that would do something? Not a very good idea. Tape has mold on it. Does not go into any modes. Yeah, so there's a whole bunch of things that need to be checked because there is some sort of communication interface between the CPUs. As I remember looking at that in there's data. Is that common to the CPUs? Yes, see that goes into data there. And there's other clocks. Clock 3, clock 2. I wonder if those are related to data or something else. And they go up here. Data, oscillator. Must be more CPUs somewhere else. Probably because the front board has got more control CPU things on it. Concerned that there's too much ripple on the power supply. That might be upsetting things. So I have to look where is the 5 volt power supply coming from. And then see if we can make that better. See if that changes anything. Then we start looking at the communications between the CPUs and see if that's doing anything interesting. See what's going on under there. It's a RF modulator, not a power supply. That's all video looking stuff there. Looking in this corner here, is there a problem? Because it looks like there's some residue on the board, but I think this might be flux residue, not capacitor juice squirted out of it. The annoying thing is we're probably going to have to take this whole board off. And yeah, that's going to mean taking off all of those connectors down the side there. It's pretty annoying. I think that might be audio. Oh no, it says trick play. Oh yeah, and audio. Okay, so it's multiple things. So we probably don't have to worry about that yet. I think all the things we need to worry about are on this bottom board. Just looking, is there a adjustment for power supply levels? Don't see one. Anyway, I'm going to have to work out where the 5 volts comes from and see what we can do about that. It's now some weeks later, happy 2023, and I've pretty much given up on this machine because I can't find anything that's obviously wrong with it. I was concerned about the power supply and previously when we were looking at this as part of the live stream, because it looked noisy, but it actually was my poor probing, because I think I'd clipped the ground over here somewhere just to give it a bit of a poke around, and you must never do that if you want to measure signal integrity. There's no ground plane in this board. It's really, really important that you measure with a ground as close as possible to what you're measuring. The worst thing you can do is hook up this massive loop like that, because then you've got an inductor. The best thing you can do is get rid of that, because that is a major source of problems, and instead put a little spring off of this so you can probe with reference right to the thing that you're probing. Anyway, when you connect a ground right near the 5-volt regulator, which is here, you get a perfectly clean voltage from it. The voltage is stable and good, so that's fine. I've confirmed the oscillator 4 MHz, that's fine. Confirmed the reset, which comes out of over here, that's fine. I've resoldered these chips in case there's something dodgy about them, even though they were probably fine. I just noticed, looks like there's a bridge there. Wonder if that matters. Anyway, I've also metered across all this ribbon cable, because supposedly that can go dodgy. And I've looked on a website. There you go, it's not shorted now. powellsite.com. They have a page on this machine, and under their troubleshooting for appears dead, it said check the fuse around the center of the board, which is there on the 5-volt regulator, which is there. That's fine on this machine. And then they said otherwise suspect faulty CPUs, because they're and that they're very difficult to replace because of the way they're soldered on. So that's what I'm suspecting, because I've spent quite a bit of time looking at the this diagram here, and which shows the interaction of data between the 3 CPUs, the one that's on this front board and the 2 that we can see on the bottom of the PCB. And then they've got serial to parallel I/O expanders, and you see the common reset, common clock, and then there's an interrupt which comes out of the one that's on the front and goes to the other ones, which they call real-time controls. That's a periodic interrupt that I guess keeps them all in sync. There must be interrupt routines that run in here to keep them locked to what's going on in here. And there's 2 clocks coming out of here, which one they go to each CPU. There's serial output from here, which is called data 1 to 2, which means CPU 1 to 2 goes to the serial in, and then there's serial out here, data 2 to 3, which goes from CPU 2 to 3, and then there's serial out here, data 3 to 1. So there's a ring of data transfer, and I can see that it looks fine, but I don't know if it's correct, and there's no description of what packets should be in that data. They give you these tables which just show the pin state in various modes, which I don't even know what mode I'm in because it doesn't go in any mode. Presumably it's stopped. It's in stop mode, but there's no timing diagram showing what should be in the data that gets sent between the CPUs. They just say it's going to be high or low in this form, and that's kind of what I see. I've tried pushing the buttons on the front while looking at that data to see, because presumably the scanning of the buttons is included as part of the data, maybe, but I can't see any response there. And the data on this one here, which I think that just goes to drive the LEDs, which I think is what's shown on here. Is it that one, IC2? FR4 IC2, FR4 IC2. Yeah, that just drives the LEDs. Oh, and it does some other things. The data in there looked a bit weird. It didn't seem very stable. I don't know. So there you go. If anybody has any ideas what I could look at on this thing. But if it needs a new chip, then that's not going to happen because I don't have any more chips. I don't have another one of these VCRs, and yeah, I don't know if these were used in others. Oh, that wire fell off. Okay. So we're going to put this to one side, and if anybody has any ideas, or if I think of something, maybe I'll revisit it, but it's pretty unlikely because I've got so many other machines to look through and show you, and yeah, unless somebody comes up with something that seems plausible to me and that I'm willing to try, then that's it for Sony SL-F1E beta VCR with a weird kind of not really behaving problem. I was just wondering perhaps what we should do as a final thing, just for fun. Just, there you go, it's still crazy, and that's not just running. If you hold it, you can feel it going backwards and forwards, so it's constantly changing direction. And then you turn it on again and it goes quiet, but the machine's not working. You can't do anything. You're expecting that you'd be able to push the eject button and that will start running again to eject it, but nope. So the clock looked too nice to be the problem, because I was thinking maybe the CPU clock's gone bad. But it seems like it's okay. Presumably, because on this side of it, that's all wires, and I don't really want to unplug all of that right now, so probably we can undo it from this side and have it hinge off, maybe? I don't think this will reveal anything new, but we'll be able to see what's under there at least. Yes, look at that. And yeah, when I saw on that PAL site about the fuses, I did check over here by the 9-volt regulator. There is a designated for another fuse which didn't meter out as good, but I see now, as suspected, there's nothing soldered into that position other than a wire link going to somewhere. I was wondering maybe I should override the clock with something from a function generator to see if that calms it down. And someone's definitely already had a go at this, because there are some tracks there with the silk screen scraped off of it. So someone's measured something on there. Which is probably why there's such messy flux on some of these chips, because they must have tried either resoldering it or replacing them. So that's got a Toshiba. There's another Toshiba there. So it's probably still the original chip. It's got all these hybrid module things. Orange Sony special hybrid module ICs. So who knows? It's probably just one little thing is wrong, and because of that, this whole thing is now not functioning. Yeah, so it's got individual motors for the take up and supply reels. Should we take that apart just to look at it? Soon, eventually, we'll get to the Panasonic VCRs, portable VCRs, and we'll see how similar those are. Quite similar. With direct drive reels. Oh, they're both fully direct drive, not... Yeah, on the Panasonic, like the NV180, one of these has got a planetary gear on it so that it's geared down slightly. These are both direct, and there's some brakes there. Pretty nice. Simple aluminium plate chassis, not a nice die-cast one. Yeah, there's probably some stuff that has to click in there, is there? What does the... Oh, it's the loading motor, isn't it, that does the eject mechanism, all that business there. Video head, capstan. Yeah, so unfortunately we weren't able to get this machine working at the moment. But we'll move on to other stuff. Thanks for watching. More than 80 videos now. And like, comment and subscribe. And if you want to support the channel, then there's a link in the description. Or just enjoy watching the videos. And hopefully there will be plenty more. Another year's worth easily. Just the amount of stuff I've got here waiting to have videos made of it. Let me try it again in case poking it around woke it up. Exactly the same, no difference. Great, well there you go. Sony SL-F1E Beta Portable VCR.